Now in the multi-product case, we know that if um, yi is greater than 0, we say that this is the good that the firm is producing. That is, I is the produced or I is a good that is produced or supplied by the firm. If there is the opposite case of this one, that is if yi is less than 0, then the good is consumed by the firm. Therefore, value of yi greater than 0 states that yi is an output, and yi less than 0 states that it is the input. But if y is equal to 0, the good is neither produced nor it is consumed. That is, it is neither the output of the firm nor it is the input of the firm. Now using this labeling, we can rewrite the implicit production function constraint in the general case as g y1 y2 till yn is equal to gy is less than equal to 0. What does the statement mean? This is an implicit statement. Why? Because we know that the value of y is equal to is the function of inputs. Okay. Now what happens is that if this is an explicit function. If we convert this explicit function into an implicit function, what we do is that we will shift this function towards the left hand side, and therefore it will become g of y1, y2, all the inputs that are utilized in the production function. It is equal to g y less than equal to 0. If it is less than 0, we will say that it is an input. If in the other case y is equal to y1, y2 till yn, okay, it is also defined as the net output vector. So therefore, yi are also referred to as net puts. Why net puts? Because it can be an input or it can be an output as well. Now when gy is less than 0, when the function, implicit function, that is gy is less than 0, there is output inefficiency. Why is there output inefficiency? Because we say that all the resources are not completely utilized. For the efficient allocation of resources, earlier also we said that the function should be equal to 0. So therefore, in this case also, if gy is less than 0, there is output inefficiency, and when gy is equal to 0, there is output efficiency. So therefore, this condition remains the same as it was before. A technically infeasible net output vector is indicated by gy greater than 0. What is an infeasible solution? That is now very much clear to you because we have studied that in the previous lecture as well. This is the production possibility frontier. All the points lying above this production possibility frontier are the infeasible net output vectors. Clear? Therefore, over here gy is greater than 0. At this point gy is less than 0, and on this line gy is equal to 0. There, notice that an increase in yi means that if I is an input, what do we mean by y to be an input? When the value of yi is less than 0. Okay. Now when there is an increase in yi, it means that if I is an input, the use of input has been reduced. Why? Because we know that if the when the value of yi is less than 0, then y will be considered as an input for the production company. So when the value of yi is -2, if it is increased, it will become -3, let's suppose, and then further increased, it will become -4. So the use of the input will be reduced in this case. That is, -4 is now a smaller value than -2. So therefore, I'll explain the statement again to you, that an increase in yi, -2 say -3 and -3 say -4, it means that if I is an input, that is the value of yi jo hai, it is less than 0. In all these cases it is less than 0. The use of the input has been reduced. Every negative value in absolute terms, although it is greater, but if the negative sign is associated to it, it becomes a smaller value. Therefore, yi is measured along the negative part of the relevant axis if it is an input. Okay. Now when gy is equal to 0, we say that it is technically infeasible to increase an output or reduce an input without reducing the level of some other net output. We know that when gy is equal to 0, it simply means that the firm is producing the efficient firm is utilizing the resources efficiently, and therefore it is producing efficient level of output. So therefore, if gy is equal to 0, what does it mean? It means that it is technically infeasible to increase an output or reduce an input without reducing the other level of some other level of net output, that is reducing some other output or increasing some other input. Okay, we can understand this with the help of again this diagram. If the firm is producing on this curve, this is one input, this is input number 2, this is input number 1. Okay, if the firm wants to reduce the utilization of input 2, it has to increase the if the firm has to increase the utilization of output 1, then what it has to do, it has to reduce the utilization of output 2. So therefore, it is technically infeasible to increase output or reduce an input without reducing the level of some other net output, that is reducing some other output or increasing some other input. Therefore, this implies that the partial derivative gi are always positive at gy is equal to 0. That is the first order condition or necessary condition which we have studied in mathematical economics. The partial derivatives over here of this function gi, that is given the I number of given the I number of inputs, okay, they are always positive at gy is equal to 0. To reflect the fact that ceteris paribus increase in yi, that is by increasing the value of yi, any of the input, reducing an input or increasing an input are not technically feasible because it would lead to this situation. If we increase the value of yi, for that we have to reduce the input or reduce, then what will happen is that the value of g will become greater than 0, which is a situation which we do not want. We want g to be equal to 0. Using the implicit function rule on gy is equal to 0 and allowing only yi and yj to change. Therefore, then we will have dy, rate of change of y, I with reference to rate of change of yj is equal to the negative of the ratio of the function of gj divided by gi. Here I and j both are equal to the number of inputs that are used in the production function. That is, it starts from 1, it's a positive number and it can move on to any finite number given the number of goods that are produced by the firm. This can be a given number of this can be given a number of interpretations depending on whether yi's and yj's are positive or negative as follows. Now, what are the different interpretations? We will move to them. Now, suppose yi is less than 0 and yj is less than 0. Now, when you see this condition, instead of directly moving to the theory, you can also make this thing in your mind that what the statement is saying. You can interpret this result from the statement as well. How we know that yi is less than 0? Whenever the value of y is less than 0, then that y is used as an input in the production process. Similarly, yj is also less than 0. What do we mean by yj is less than 0? It also means the same. It means that if the value of yj is less than 0, then this y is used as an input in the production process. Therefore, yi and yj both are consumed by the firm to produce the given level of output. These two y's are not the levels of output because their values are less than 0. That is, their values are negative. Both goods are input. Now let's move to the theoretical part. Now we know that both goods are inputs. So that dyi divided by dyj is the rate at which one input can be substituted for another when all other goods are held constant. Now we are given two goods, I and j. Okay, what will happen is that if you want to increase the utilization of one input, then we have to reduce the utilization of other input. Therefore, we can substitute one good for the other by keeping all the other inputs and outputs constant. It is therefore the negative of the marginal rate of technical substitution. Over here, we will have a marginal rate of technical substitution. Why? Because we are increasing the utilization of one input and decreasing the utilization of the other input. It is the slope of isoquant, which in the multi-product case is the boundary of the set of yi and yj combinations, which will produce just a in the multi-product case is the boundary of the set yi, yj combinations, which will just produce a given level of the firm's output with all other inputs held constant. Now, when we have this isoquant curve, we have the marginal rate of substitution or marginal rate of technical substitution. Its value should be negative. Why? Because the slope of it is the slope of isoquant, which in the case of more than one good is the boundary. Now this is the boundary of this set of yi's and yj combinations, which will produce a given level of the firm's output. Suppose this is I level of outputs with all the other inputs held constant. For example, in the single output two input case, this one, single output two input case, one input is this one, the other input is this one at the x-axis. We considered in the previous sections, we have remembered that an increase in yi means a decrease in z1. That is dy2 divided by dy1 is equal to g1 divided by g2. That is rate of change of the y2 to the rate of change of the y1 is equal to the positive of the ratios of g1 and g2. g1 and g2 are the functions, implicit functions, and it is the negative of the explicit functions, that is minus f1. That is negative of explicit functions, that is f1 divided by f2 is equal to minus mrts of 2, 1. That is marginal rate of technical substitution of 2 for 1. That is of the input 2 for input 1. Okay, now let's move ahead. What we have over here is, let me rub this. Now the second case is, now you people also think about it yourself and make an assumption in your mind that what does it say if yi is greater than 0 and yj is less than 0. Now this value is greater than 0. What does it mean? It means that yi is the level of output, because it is positive and output is always positive. Yj is less than 0. We know that whenever the value of y is less than 0, it is an input. So therefore, good I is an input, good I is an output. Why? Because it is greater than 0. And j is an input. So that dy I, that is the rate of change in the output to the rate of change in the input, is the rate at which the output of I changes when the input j is reduced with all other outputs and inputs held constant. In this case, the rate of change of one variable due to the rate of change of the other variable will change the interpretation. How? It is the rate at which the output of I, it changes. I is the isoquant curve. Here it is the rate at which the output of I changes when the input j is reduced with all other outputs and inputs held constant. Therefore, it is negative of the marginal product of input j in the production of output I. Therefore, जो आउटपुट j जो हमारे पास इनपुट j है, why is it input? Because yj is less than 0. The marginal product of input j in the production of output I is negative. That is dy3 divided by dy1 is equal to negative of g1 by g3. It is the negative of g1 by g3, and the function will become a negative function of f1, and therefore it is equal to minus mp1. Now we move forward ahead to the third case. What is the third case, or what will be the third case? It will be yi is also greater than 0 and yj is also greater than 0. Now what happens over here is that both yi and yj are the outputs. They are not the inputs. When both are outputs, so dyi, that is the rate of change in the output I to the rate of change in the output j, is the rate at which the output of I varies as the output of j is increased when all the inputs and all the other outputs are held constant. In this case, what happens is that it is the rate at which the output of I varies. It changes as the output of J is increased by keeping all the other inputs and outputs held constant. Therefore, यहाँ पे हमारे पास what we will get is this is the negative of the marginal rate of transformation of I into J. In this case, we will get the marginal rate of transformation of I into J. Why? Because the rate of change of one output to the rate of change of the other output is studied in this case. I'll very briefly go through these three cases by defining the marginal rate of substitution, marginal rate of transformation, and marginal product, where which concept comes. When we want to study the rate of change of one output with reference to the rate of change of the other output, then we have the negative of marginal rate of transformation. Therefore, in this case, we will have the marginal rate of transformation, and of course, it will also be the negative in value. Now, in the second one, when we are studying the rate of change of an output to the rate of change of an input, then we get the negative of the marginal product of input J in the production of output. Clear? When we are studying the rate of change of an output to the rate of change of an input, then we get the marginal product of an input, that is J, in the production of output I. And in this one, where we are studying the rate of change of one input with reference to the rate of change of the other input, then we get the marginal rate of technical substitution. I'll stop the recording over here. If there is any question, you can ask me. Otherwise, we'll proceed forward.